All right, so let's talk about what a can is. So we have a can, so it's got, looks like that, right? So the volume will be area of the bottom, which is pi r squared, times the height. And they tell me it has the volume of 1,000. Okay, so we're going to use that to substitute. And you probably can tell we're going to use it to substitute for h. So we get 1,000 divided by pi r squared. Okay, so what is it we're trying to minimize, and what is it we're trying to take the derivative of? So minimize surface area. So I'm going to want to find the surface area equation and set it equal to 0. Okay, so it has a top, so it's got surface area would be bottom and top. So I'd have 2 pi r squareds, and then the lateral surface area, like all of this, would be 2 pi r h. So that would give me all of the sides. All right, so now we're going to substitute this in. So I get 2 pi r squared plus 2 pi r, 1,000 divided by pi r squared. Let's simplify that. So plus, so okay, I can see the pi's cancel. One of the r's cancels, right? So I get a 2,000 over an r. Okay, so I'm just going to rewrite that so I can see what that is. So 2 pi r squared plus 2,000 r to the negative 1. Now let's take the derivative. So I get 4 pi r minus 2,000 r to the negative 2, and I'm going to encourage you to write it in the denominator. Okay, set it equal to 0, so 4 pi r is 2,000 over r squared. And so let's multiply both sides by r squared, right? R squared. So I get 4 pi r cubed is equal to 2,000. And then continuing to solve for r, right? R cubed, if I divide through by 4 pi, I get, that's supposed to be 2,000, 500 over pi, right? And so r is equal to 500 over pi to the 1/3 power. So then I'm looking to find out what the dimensions are, right? And so here was the equation for h. So I'm going to put this in here. So I get h is equal to 1,000 pi. And if I have something squared and it's all to the 1/3 power, that's 2/3 of 500 over pi. Pretty ugly, but it's the answer. All right, so let's look at this next one. So I want to talk about these two and comparing and contrasting how to approach them. So we have a rectangular poster that has an area of 180. So the whole thing is of 180. So I'm going to encourage you to say this x times y, x times y is 180. Because you can see that this is going to be easy to say y is equal to 180 over x, right? When we have a constraint, we want to make it easy to substitute in. Okay, so then what is it we want to do? We've got margins, so 2-inch margin at the top, and 1-inch margin all on the other sides. Okay, and so what they want us to do is find the largest printed area. So that would be this. So the printed area in terms of x's and y's, right? So the printed area would be, okay, take this x and subtract off 2. So the printed area would be x minus 2, right? This whole distance is x, take away the 2. And then the y, all of this is the y. And so I'm going to take the y and I'm going to subtract off 3. Again, I'm going to substitute this in. So I get x minus 2. And then I'm going to put the 180 over x minus 3. You can choose to multiply this out or keep it as it is. I'm going to multiply it out because I think that's helpful. So I don't have to do product rule. So if I multiply this times this, Oh, look at that. That's just 180. And if I multiply this times this, that's minus 3x. And then if I multiply this times this, that gives me negative 360 over x. And then if I multiply this times this, that gives me a minus 6. Okay, so now let's take the derivative, because that's what we want to do. We want to maximize that printed area. So I get negative 3. And taking the derivative of this, you know, is going to be plus 360 over x squared, and the derivative of that is 0. So set that equal to 0. So I get 3 equals 360 over x squared. So x squared is 120. So x is equal to the square root of 120. We're talking about the sides of a piece of paper, so it has to be positive, right? And so that's the x. So how do I find the y? We put it back in here. So I get the y is equal to 180 divided by root 120.